Over 13 billion years ago, scattered clouds of gas and dust began being pulled together by gravity, eventually forming the Milky Way galaxy that our little planet is a part of. Welcome to Tiny Matters. I'm Sam Jones, and I'm joined by my co-host, Deboki Chakravarti. Today on the show, Deboki and I are talking all about our galaxy with guest Moya McTeer, an astrophysicist and folklorist who just wrote a book titled The Milky Way, an autobiography of our galaxy. And yes, you did hear that right. This book is the Milky Way's autobiography, because after a few billion years of bearing witness to life on Earth, of watching 100 billion humans go about their day-to-day lives, of feeling unbelievably lonely, and of hearing its own story told by others, the Milky Way galaxy would like a chance to speak for itself. All 100 billion stars and 50 undecillion tons of gas of it. So for those of you like me who didn't know, an undecillion is a 1 followed by 36 zeros. In other words, it's a whole lot of gas. So Deboki and I have left a link to the book in the episode description, and we hope that you check it out. It's truly a fascinating read about the history and future of our universe, what people have uncovered about it, and what they've been inspired to create by studying it. We hope you enjoy our conversation with astrophysicist and folklorist Moya McTeer. Thanks so much for being here. We're both really psyched to talk with you about your book.
Yay, me too.
I think our audience might be interested in hearing about where you grew up and maybe how it led to your curiosity to explore and understand the outdoors, including the night sky.
Yes, I love talking about this because I think it's a bit of a surprise for people. So I grew up in the middle of the woods in rural Pennsylvania. And when I say woods, I mean like in the holler, surrounded by like 25 acres of deep forest. And I lived in a log cabin without running water, but we did have electricity. And it was just a really weird place to grow up. And because I was kind of an only child, I was my mom's only child, I got bored easily. So I had to spend my time in the woods, and I spent a lot of time reading. So that I just have always been very into books. I've always been very into nature and like fantasy and fiction. But I was not very into space. I didn't find my interest in astronomy until my sophomore year of college, and it was actually a total fluke. One of my friends dragged me with her to an astronomy class, and the professor said we would get free pizza every week, so I signed up for the class.
I went to a lot of events and, course intros just to get free pizza and or bagels. That was a huge motivator. So I understand that.
Yeah, when you are a broke college student, you will go after all the free food, especially free carbs that you can.
Yes. Yeah, I'm very tempted to say that this pizza was life-changing, but also
yes.
We've all explored so many free pizza opportunities that you never know which one is going to be the one that changes your life.
Yeah, the multiverse is actually just all of the different possible universes that are the consequences of your pizza decisions.
Yes, yes, exactly.
So I guess the long story short answer to this is I got into astronomy because of free pizza. I wasn't interested in it as a kid, and now as an adult, I'm interested in it because I've seen how it can inspire people to get into science. But I do not think it is inherently more interesting than other sciences. And I need to bring in some folklore and some fantasy elements to keep my attention on it, which is what you see in this book.
I was going to say, speaking about the folklore, because you've studied folklore, right? This was, so was that something that you felt initially was really separate from the astronomy, or did you immediately see a connection between the two?
That's a great question. I, like most people, initially thought that they were pretty separate. When I was in college and I decided to study both of these, a lot of people initially assumed that I would study constellations or astrology because that's the easy intersection between them. And it took many years for me to start seeing the other connections. So I do see a lot of connections now, but I did not at first.
That's really cool. Deboki, do you want to kick off some of the creative choices questions that we have?
Yeah, let's start with the big one. So this book is told from the perspective of the Milky Way. It's an autobiography of the Milky Way. So I would love to know why the Milky Way in particular. Like, why not the sun? Why not some other planet? What was it about the Milky Way that you were most excited about?
Ooh, there were so many factors that went into this decision. One was that I wanted to tell this story that has been told before from a new perspective. And I was like, who am I, Moya McTeer, to try and add to what other scientists have written about the Milky Way? But like the Milky Way itself, we have not heard from it yet. And so it was a new perspective that I was excited about. I wrote this book while I was finishing up my PhD studying stars moving around the Milky Way galaxy. So I was already in the mindset of the galaxy. That was point number 2. And then point number 3 was that I really wanted people to expand their perspective after reading this book. I wanted them to zoom out from their tiny little human experience of the world. And for us, what could be bigger than the galaxy we live in? So it was a perfect storm of things pointing me in the direction of writing it from the Milky Way's point of view.
That's really cool. And so now let's talk a little bit about the Milky Way's tone. I would say the Milky Way is sassy for sure. I would say sass is definitely a word for it, but also this like interest / incredulous take on humanity, right? There's a lot of really funny moments where the Milky Way will say something like, I can't believe you humans, but also you're very tenacious. I respect that. It's this interesting thing. Yeah. But sass is an underlying current. And so how did you decide on that as the Milky Way's tone?
It seemed fun. My editor and I did try out a few different voices, like maybe a frat bro, or maybe like a business mogul type person, or like an uppity British royal, like those tones. And I wanted everything to be inspired by the science, thinking about what type of personality would arise from a sentient being that had these experiences of living alone for billions of years, of having its sole mission in life being to create stars that it then sees die over and over and over again. And to me, it just made sense that the galaxy would be, in the past, kind of dealing with an inferiority complex because everything that it works on breaks, but also seeing that it is the strongest, biggest galaxy in the local group. So that gives it this kind of like cocky air to it. I don't know. It just kind of happened that way. And then as I started to find the voice, I would see inspiration for it in life. One big inspiration was my cat Cosmo, because cats are very like, yeah, I don't care that you're here, but sometimes you're amusing, and that's useful to me. So I tried to channel that.
Yeah, I definitely, while I was reading this, my cat was sitting there as he does. And I was like, oh, I get it. This is what my cat would say if he were a galaxy. This is how he would address me.
Yeah, for sure.
As you're exploring these different voices, you're essentially sort of anthropomorphizing the Milky Way in a way.
Mm-hmm.
And I'm really curious about how you feel about that. What kind of factors were you taking into consideration, especially, maybe even deciding between these voices, but also thinking about this versus how you might be talking about the Milky Way in academia? Like, were there any considerations that you took into account as you were finding the voice that you felt was right for the Milky Way?
Yeah, I was trying to take time scale into account, because that's something that's really hard for us humans to think about. Even hundreds of years, let alone millions or billions of years, which is the timescale that the Milky Way is used to. So I tried to keep that in mind. I tried to find the balance between making these scientific concepts too anthropomorphized, or too metaphorical, while still, I don't know, having some art in there and having some metaphors and analogies that people who are not scientists can use to help internalize the information. Because that's how I learn best, I think. I really think in terms of metaphors, and this whole book was just an extended, drawn-out metaphor.
Mm-hmm.
I know that a lot of my fellow astronomers don't love anthropomorphizing things. I have had conversations before I wrote the book about science journalists maybe leaning too far into anthropomorphizing space objects and how it gives the public the wrong idea. But I think that I had to lean into the conceit of this book. And if you're going to read a book written from the perspective of the Milky Way, everything about it better be anthropomorphized.
Right. Yeah, absolutely. Absolutely. Deboki touched on this a bit earlier, and I think you mentioned it, but being an astrophysicist, also a folklorist, how did that inform how you wrote about the Milky Way? Because there are so many concepts there, right? And I think it was just like, wow, how did she decide how to unpack all of this material and also not just talk about the science, but talk about the folklore and have this really interesting melding of info? What was your approach to that?
I was just trying to tell people what I thought was cool.
Yeah.
and in studying both astro and folklore, I have come to see them as like a single spectrum of understanding of the universe. Thousands of years ago, the way we understood the universe was through these myths and these stories that we would tell. We learned a lot about the universe by trying to tell these myths. We learned about eclipses and when they should happen and what to expect when they do. We understood the changing of the seasons through mythology and folklore. And then over time, we started to understand the science behind it. So from the Milky Way's perspective, mythology is a huge part of how humans have understood space throughout time, and it needed to be included in the book. So that was a no-brainer for me. I was absolutely going to include the folklore, but I wasn't sure how to write it from the Milky Way's perspective. Like, would it appreciate the folklore? Would it think that the folklore was silly or stupid? And ultimately, I decided that it appreciated it, because the Milky Way appreciates anything that humans do to understand it better. And it knows that we are young. We are very early in our journey of understanding the science of the Milky Way. We have a lot of folklore about it. So, yeah, the Milky Way is like, oh, you humans are cute, and these stories are adorable, and I guess they tell you about me, so good job.
In the book, the Milky Way seems to be a general fan of myths, like you just mentioned, and even says something along the lines of having myths like those, even in Star Trek or Star Wars, they motivate humans to achieve feats currently out of reach, which I loved because, and this is something that you just said, right? There are all of these things that the Milky Way has sort of inspired us to want to understand or potentially do. Mm-hmm. For example, satellite technology was written about in sci-fi before it was a reality. My point of all of this is, for you, someone who is an astrophysicist and folklorist, do you find the modern or ancient myths more compelling? And do you maybe have one or two favorites?
We can give you top 5.
Yeah, I was gonna say you can extend beyond that. I know this is a big ask for someone who loves thinking about these myths. Yeah. And I should also note, for anyone who hasn't read the book yet, there are a lot of myths in there. So this is a big ask of me right now. So feel free to modify as you would like, Moya.
Thank you. Yes, this is an audio medium, so listeners, you can't tell, but I just copied the Scream painting. I was like, I can't choose one. No, so I'd say that ancient myths to me are more interesting because I love seeing how people observed the world around them and then came up with explanations for what they saw. Whereas modern myths, I think that's more like science fiction and fantasy and things that we create now. But it's also, I think I say in the book that there's the myth of the totally altruistic politician or like the philanthropic billionaire. These are myths that we tell ourselves, stories of things that don't really exist, but we wish they did. And I don't know. To me, that's just not as compelling as ancient myths. So I prefer those. And I could not choose a favorite. But there are some that stick with me. I'd say I put this in the book because I could not leave it out. There's this beautiful story from the Khoisan people of South Africa about how the Milky Way was created. And it says that in the beginning, the sky was totally dark. There were no stars and you couldn't see anything at night. And there was this young girl who, in some stories, was dancing around a fire. In other stories, she was, cooking around a fire. There was a fire involved, and this little girl needed to get home, but she couldn't see how to get there. So she took the embers from the fire and threw them up into the sky, and that became the stars that lit her way home. And I absolutely love that myth.
Yeah, me too.
There are so many cultures around the world that put their origins in the sky because that's where a lot of their gods lived, and the gods were the ones who created the universe. There are also a lot of people who put their afterlives among the stars. I know that there are other cultures in Africa who said that the stars were the souls of your ancestors looking down on you. There are places around the world that thought the stars were pokes, like these points of light, these holes in a big blanket that covered the firmament that covered the sphere on top of us, and behind that was a world of fire, and so those holes are the stars looking through to the world of fire beyond. Yeah, there's just too much good stuff out there for me to choose.
Yeah, I feel like hearing about all of these different myths just makes you appreciate how creative humans have been in their interpretations, where like you just get these stories that are all about the same thing, but not. They're all different, even if they have these themes kind of running through them.
Yeah. Sorry, not to interrupt. I absolutely love that, because when you look at space mythology from around the world, you can see things that are very different, but you can also see ways where cultures from opposite sides of the planet were so similar. We call the galaxy the Milky Way, but that is not what every culture on Earth calls it. But a lot of cultures do think that it looks like milk. So we call it the Milky Way because it comes from Greek mythology, this story of Hera spurting breast milk into the heavens, and that became the Milky Way. But there are other cultures where it's like goat milk that got spilled or something. And just the fact that you can see these connections, that people separately thought of these stories, shows us how similar we are as humans, even if we never actually come into direct contact with each other.
Yeah, not to be too literal about it, but there's something so life focused too about using milk to describe it.
Mm-hmm, for sure. Yeah, even the word galaxy comes from the ancient Greek word for milk, galaxios, or something.
So one of the other things from this modern myths chapter that I was thinking of as I was reading it is the way that it talks a lot about like the limitations of our modern myths, where, you know, maybe we have these myths that are written from a very human-centric point of view and really rooted in our idea of positioning everything in space around us, whether that's emotionally, physically, or also just rooted in when things are written, especially for modern stories, like when the technology has been developed and things that have happened since then to change our knowledge. Or I think one of the examples is about our definition of nebulas has really evolved and become more specific over time. And so obviously, you know, those limitations, they come up when we're working to talk about science and fiction and also nonfiction. And so I was just wondering, you know, someone who's talking about science and space, how do you see those limitations shaping the way you approach talking about them?
Everything you write is a reflection of that snapshot in time, and it is annoying. I can't help but wonder how people 50 years from now might see this book. What will we learn in the next few decades that make this book obsolete? Or what will we uncover that turns something that I thought was very true in the book into something that is not true anymore? And this is just like my philosophical musing. If you discover that something is false later, does that make it a lie beforehand? I don't know. But yeah, these limitations, from my perspective as a new writer, are scary, because it means that I can't always be sure that what I write is always going to be true in the way that I mean it to be true. So that's unfortunate. It also means that the sources we have, we can't like, we have to be careful of how much stock we put in them. I reference the prose and poetic Eddas from Norse culture in the book, but these Eddas that tell us a lot about Norse mythology were written in the 12th and 13th centuries by kind of Christian monks long after these myths had actually been created, and so they were shifted. But this is the information we have. Like, we don't actually have the quote unquote original Norse myths, but I still included them in the book. So those, yeah. I don't know if I actually answered your questions, but
no, I mean, I think it's a pretty open-ended thing.
Yeah. The limitations mean that I'm going to have to write another book at some point when we learn new things.
Yeah, volume 2, like some sequel of sorts. And I was going to say, I feel like if we look back 50 years in the future, if we look back at your book, I don't think anyone would ever say this is a lie. But I think they would say, wow, look how much we've learned about this thing since, you know? Mm-hmm. That's how I feel when I read a genetics book from the 1970s. I'm like, oh, wow, okay, all right, sure. It was really, for the time, so impressive that even that information was there. But now you can kind of look back and say, what were they thinking? But they were thinking what they were able to based on the information present. So, it's all relative.
It does show that science is moving in the right direction. If we are making progress and learning new things, then we're doing it right.
Let's see, Deboki, how do you want to approach this next part? Maybe from here, it makes sense to sort of backtrack a little bit and think about earlier in the book, talking about the hometown, the hometown of our Milky Way. I really liked that chapter a lot because I felt like it provided essentially a bit of a map for where we are located, because I'll be honest, I did not know a lot about our galaxy or the other ones, so it was really helpful.
I love the hometown chapter because I felt like it gave such a sense of setting to everything, which is not how I think of the Milky Way, where I'm like, where is the Milky Way's home? Like, where does it live? But essentially, this hometown chapter for listeners, it's where we're learning about not just like where the Milky Way lives, but who the Milky Way's neighbors are, including the large Magellan. Oh man, I looked up this pronunciation. The Magellanic. Yes, thank you. The large Magellanic Cloud, the small Magellanic Cloud, and the Triangulum. And they also, just like the Milky Way, they have their own distinct personalities, and they also have their own distinct relationships as viewed by the Milky Way. So we talked a little bit about how you envision the Milky Way. So I would also love to now know how you then thought about its neighbors. How did you decide on what their lives were like?
Yes. Well, so the Milky Way is one galaxy in a group of 50 or so galaxies that we call the local group. And I decided to make our local group our galactic neighborhood. And then if you expand that out, we are in a cluster, a super cluster of galaxies that could be like our state or country or whatever. So the Milky Way spends most of its time with its galactic neighbors that are mostly these little dwarf galaxies that orbit the Milky Way and Andromeda. And then there are some that just orbit the whole cloud. By far the closest to us are the large and small Magellanic Clouds. So I knew that they would be interacting with the Milky Way the most. And I wanted one of them to be close to the Milky Way. I wanted the Milky Way to have a good relationship with one of them. And then just to add some fun, I wanted the Milky Way to hate one of them. Because if I have this sassy, cranky, cocky character, it's not going to get along with all of its neighbors.
It's primed for a bit of soap opera drama, I would say.
Yeah.
Oh, and there is drama when you get to this chapter. You learn about how Larry, the large Magellanic Cloud, is too boring for the Milky Way, too dull, so the Milky Way doesn't like it. You learn about the Triangulum galaxy, which is essentially the Milky Way's top competition for its romantic interest, the Andromeda galaxy. So Triangulum and the Milky Way are battling it out, and in deciding which one was which one does the Milky Way get along with, which one does it hate, and which one is its arch nemesis, that came from turning gravity into affection, or into the relationship that these galaxies have, because galaxies are interacting gravitationally all the time. They merge, and I called those mergers marriages or flings, depending on how major the merger was. So the Large Magellanic Cloud, it's bigger than the Small Magellanic Cloud, but much smaller than the Milky Way, and it doesn't produce as many stars as the Milky Way thinks it should. Keep in mind that the Milky Way is the narrator in its story, and you can decide how reliable or unreliable it is. But Larry doesn't produce as much stars, so in the Milky Way's mind, it's just not worth any attention. And Triangulum is the third largest galaxy in the group, and it feels bad about that. Like, it wants to take the Milky Way's spot, but it can't. And so it's just bitter about that, and that plays out in the relationship.
Speaking of the drama, later on in the book, we get to the crush chapter where we learn about like the true object, like the one thing that the Milky Way seems to truly love in a pure way, which is Andromeda, also a neighbor. And I love a good love story. So I love the way that this chapter kind of unfolds. We know it's coming. There's all these hints, and then we get there. And so we learn about the love for Andromeda, how they're sending messages via stars. So what I would love to know, since we're getting this from the Milky Way's perspective, if you were thinking about this from Andromeda's perspective, what would they love about the Milky Way?
Oh, I love this question. I think that the Andromeda galaxy loves how the Milky Way just like keeps trying. If you read the Inner Turmoil chapter in the book that talks about black holes and how they're kind of a metaphor for depression and mental health struggles, Andromeda sees the Milky Way dealing with this really massive black hole at its center and overcome the depression that the black hole gives it. So Andromeda appreciates that. Andromeda also just, how do I want to say this? The Milky Way has big dark matter energy. The Milky Way has BDME, and Andromeda's very into that.
Okay, so I'm going to take a, I guess, more morbid turn. Deboki, unless there's anything else you want to add about this.
I love that.
Okay, so morbid, yet I think it's very interesting. So I'm talking about the death chapter. And so I would say, so throughout the book, the Milky Way mentions many times that our species, humans, are really just existing for this blip in time. And it's true. But then in the chapter Death, the Milky Way starts talking about how the Milky Way will also die. So there are all of these different scenarios that have to do with the Milky Way's density. Correct me if I'm wrong, but sort of the varying amounts of matter or energy will impact how the Milky Way meets its ultimate demise. There's a density element to how things end, I guess.
Yes.
And so you have things like the big freeze and the big rip and the big crunch. And so I'm wondering, do you mind just sharing one scenario for the Milky Way's death that you think is really interesting?
Yeah. So when the Milky Way talks about it dying, what it's really talking about is the entire universe dying, like the ultimate fate of the universe. And that depends on the behavior of dark energy, which depends on the density of matter and energy and like the ratio between the two, not just in the Milky Way galaxy, but in the entire universe. So if dark energy, which is this force that we don't understand, that is making the universe expand at an accelerating rate, if dark energy is very, very strong, then the universe could end in what we call the big rip, where the universe continues to expand and gets so fast that galaxy clusters will start breaking apart. Right now, gravity is keeping those clusters together, but if dark energy gets really strong, it could tear galaxy clusters apart. It could tear individual galaxies apart. It could even tear individual atoms apart. Now, we don't think that this is the most likely scenario because we don't think dark energy is that strong, but we aren't sure yet. It could very well be strong enough to end in the Big Rip. And if it does, the Milky Way is going to be so mad. That is the Milky Way's least favorite possibility because that's the only scenario where the Milky Way and Andromeda get torn apart.
Yes. The love connection again.
Yeah, the Milky Way is very motivated by its emotions, by the love it feels for Andromeda, by the love it feels for its stars, by the by the loathing it has for the Large Magellanic Cloud. Like that really dominates its motivation.
We know that the Big Rip is the Milky Way's least favorite option. In your opinion, and I know that no one knows for sure, right? If we knew how the universe was going to end, people would be talking about it. Is there one that stands out to you as the least likely, or maybe there's one that you just want to talk about because you think it's cool, even if it's not likely?
Yes, I'll give you both. I'll give you one that scientists think is most likely to happen based on our observations of dark energy. We think that the big freeze is most likely, the one where the universe continues to expand, but not so much that atoms get ripped apart. Instead, things will just expand and the temperature of the universe will slowly decrease because as there's more space in the universe with the same amount of matter, you get less and less energy, and energy and temperature are related. So with less energy, you get less temperature. And then, in that scenario, all of the stars just die. No new stars are formed. The white dwarfs that get left behind eventually just radiate all of their heat away, and they are chunks of rock in space. And when there is zero energy in the universe, that would be the big freeze death. That's probably what's going to happen. The one that I think is most fun and least likely to happen is called the Big Slurp. And I love this one because it is just, it could happen at any moment. And it has to do with our particle physics. So you have to get into quantum physics to explain this, and I had a real fun time trying to explain quantum field theory in this book. But the Big Slurp would happen if, for some reason, our universe is not in the most energetically favorable state. In particular, it has to do with the Higgs boson particle. If the way that our universe creates Higgs boson particles is not basically like the easiest way for the universe to make these particles, then it could all of a sudden just drop to a more energetically favorable state, and then almost like turning a computer on and off, the entire universe would just restart with new rules of physics. We don't think it's going to happen anytime soon, but like it could happen right now.
That's wild. Do you mind giving a very brief for Deboki and I, maybe also some of our listeners, just like a quick tutorial, if possible, on the Higgs boson particles? Is that right? Did I even say that correctly?
Yes, absolutely. Okay, a quick introduction to quantum field theory. We have particles in the world that make up everything. Atoms are made up of protons and neutrons. Those protons and neutrons themselves are made up of even smaller particles called quarks. Quantum field theory says that all of these fundamental particles that can't be broken down anymore, you could think of them as particles, like little balls in space, but you can also think of them as spikes of energy. And there are different fields. Oh, this is getting complicated. There are different fields that produce different particles. So like there's the Higgs field, and a spike of energy in the Higgs field produces the Higgs boson particle. All of these particles are responsible for different things, but the Higgs boson is responsible for giving objects their mass, which is really important. Like mass determines gravity, which is really important in deciding just like how things in space work. Things in space move because of gravity. And so this particle that determines an object's mass also determines the way that it interacts gravitationally with other things. And that is the particle that could be not in the most energetically favorable state. Like it could be that the spike that produces the Higgs boson in our universe is a difficult spike for the universe to make. I feel like I'm getting so into the weeds right now.
No.
Is it making sense?
Yes.
Okay.
I think so. Yeah. I was going to say very casually, I was like, hey, Moya, would you like to maybe explain quantum physics to me in like a way that is really simple? It was not a small ask. sort of like the foundation for how everything works, if all of a sudden it was just turned off,
yes,
and then flipped back on, it could just be entirely different
rules. Yeah.
Okay.
Flipped off, the engineer in charge of the universe changes the code behind the scenes so that it works differently, and then it's turned back on. And in that scenario, at the speed of light, so too fast for us to notice, the universe would like reset itself with new rules.
So when people consider the possibility of this happening, are they able to predict what those new rules would be?
It would depend entirely on like what the Higgs boson field does.
Yeah.
It may be, I'd say there are two directions, right? The field could change in a way where the Higgs makes everything more massive, or it makes everything less massive. That would create a domino effect of drastically different rules for the universe. I did an episode of my podcast Exolore where I interviewed Dr. Chanda Prescott-Weinstein about a universe with fundamentally different physics, and it was a really hard conversation to have because I was trying to get Dr. Weinstein to say like, okay, so if quarks were more massive, would we still be able to form stars? And it's just like it's hard to say. Things would be different. But we can't say how for sure.
Yeah, that's so fascinating. Physics to me, my understanding of physics is that it is a bunch of equations that scientists are the people who understand them are very good at extrapolating from. I would love to know, do you ever reach a point, and I'm sorry, I'm so projecting from my own failures with physics here, but do you have these points, because you talked about this with the quarks too, of like, you just reach a point of like, how do I imagine this? But do you have points where you're just like, what is this equation? Do I believe my understanding of the universe is nestled into this equation and I'm supposed to trust it? Like, do you have trust issues with physics is what I want to know.
Yes, absolutely. I think everyone should have small trust issues with physics. At the end of the day, math is a convenient tool that we have created to explain what we see in the universe. Like, it is up to interpretation. Math is not as objective as we think it is because it relies on fundamental assumptions that you make. So yeah, we should have a little bit of trust. And there are a bunch of equations that my brain, I feel when I see them just shuts off. Like when I see the psi symbol, the Greek letter psi, my brain just shuts off. For some reason, when I have to think of wave numbers or when I have to think of equations that have to deal with waves in physics, it's just really hard for me. I like thinking in terms of metaphors. That's why I wrote this book. I'm a conceptual thinker. So yeah, I have a hard time with some of this math.
Deboki, sure. I feel like this is very validating for us because, so Moya, at the end of Tiny Matters episodes, we do this thing called a tiny show and tell where, we have an episode about one topic, it's narrative driven, but then at the end, we each bring something that's happened or just a random topic in science that we each talk about for, a couple of minutes. And whenever one of us brings a physics concept, the other one is like, good for you. You got this. You got this. And then at the end, we're just like, we don't know. Let's move on. It's just, so yeah.
I'm going to give you a little secret. That's what a lot of physicists are saying too. We don't know. Let's make this assumption.
This is an ego boost for me. Okay.
Good.
It seems like we were physicists all along is what I'm learning.
Yeah.
Look, I think everyone is. Everyone's a physicist.
Moya.
Everyone's a scientist.
All right. Moya's helping me feel better about my lack of physics knowledge right now and my fear of physics. So thinking about this book as a whole and sort of your inspiration or inspirations for writing it, were there any academics or writers or, things that people had created in the past that maybe inspired you initially to think, I would want to write a book one day?
I like writing. I like reading. I like writing. I love knowing things. And I really love when other people know that I know things. I'd say for writing it from the Milky Way's perspective, Anne Leckie's The Raven Tower was really formative. That book is written from the perspective of a sentient rock who's a god. So that gave me an idea of how I could write something from this different perspective. And N.K. Jemisin as a fiction writer and the way that she builds worlds that kind of defy expectations and keep you guessing along the way. And like every time I read an N.K. Jemisin book, I'm like, oh, I've never read something like this before. That feeling was something I wanted people to have when they read my book. For astronomy books, gotta shout out Dr. Chanda Prescott Weinstein again with her book The Disordered Cosmos, which really beautifully blended, I'd say, like social justice and sociology and particle physics. And then I absolutely relied a bit on that book for some of the dark matter content in the Milky Way. And Katie Mack's The End of Everything helped a lot with the death chapter, talking about the ultimate fate of the universe. So those were absolutely inspiration. But I will say that I kind of stopped reading while I was writing this book because I didn't want other people's writing styles to affect the tone and the voice that I had crafted for the Milky Way.
I guess the last thing on our list to ask you about is, what is a weird Milky Way fact that you think listeners might want to know?
A fact about the Milky Way in astronomy, or a fact about the Milky Way, the character?
Ooh, both. Can I get one of each?
Yeah. One astronomy fact about the Milky Way. I'm gonna be selfish because this is a fact that I put in the book from my own research.
Cool.
I was really proud to do that. So in grad school, I studied the galactic habitable zone, which is the place in the galaxy where we think the conditions for life like us are met. And these conditions are, you have to be far enough away from stars that you aren't affected by their radiation, but close enough to stars that you have some of these heavier elements that the stars produce. And you also have to be in the right place of the galaxy to not get swept up in the spiral arms, because that's where a lot of dangerous supernovae happen. So essentially, the galactic habitable zone in the Milky Way is centered on where our solar system is, which is an amazing coincidence. Not actually, because we're looking for factors that we need to live. So of course we found what we need. But it's this donut around the galaxy, this ring centered on our spot in the galaxy, and that's the galactic habitable zone. It's right where we are. Yay. In numbers, the galactic habitable zone is between 7 and 9 kiloparsecs from the galactic center, and our sun is 8 kiloparsecs from the galactic center. And it's specifically for stars that are between 4 and 8 billion years old.
Wow.
Because there's a time element in there too.
Yeah.
That's very cool.
Like the stars have to be at a certain point in their life.
In their evolution. Because stars that are formed very early in the universe won't have a lot of those heavier elements. So you want a relatively recently formed star, like our sun. And a fact about the Milky Way character that you will see in this book is that the Milky Way really does not like Albert Einstein.
Yes.
There are some humans that the Milky Way just has no respect for. And Albert Einstein is one of them. One human that the Milky Way loves is Jill Tarter, who was, I think, one of the founders of SETI, the Search for Extraterrestrial Intelligence Institute. And she's awesome, and the Milky Way knows it.
Has good taste.
Yeah.
She does. The Milky Way also makes a crack about Beyonce in the book, and I want everyone to know that is not the Milky Way saying that Beyonce is not worthy of respect, but also Beyonce has never made stars, and so is nowhere near as busy as our galaxy.
That's fair. That's fair. She has something that she needs to, she's accomplished a lot, but that she needs to add that to her list, I think. Yeah. Amazing. Well, Moya, this has been so much fun. Thank you so much for talking with us. You must be at this point where you're just so excited that this is finally going to be out in the world.
Yes.
I would think.
Yes, I am. This has been in my brain percolating for 2.5 years. I just really hope people get something from this book. If that something is a laugh, great. I've heard people say that they were laughing their butts off while reading this book. If that something is a shift in perspective about your human blip of an existence, then great. My advisor, after reading this book, said, it's great, but I'm worried people will think that the Milky Way is actually alive. And if that's something you get from this book, then okay, that's great too. Like, I don't know. I just hope people get something from it, because I tried to put a little bit of something in it for everyone.
Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society. I'm Sam Jones, and I was joined by my co-host, Deboki Chakravarti. This week's episode was a little different than the usual. No script, just chatting. So thank you so much to Moya McTeer for taking time to talk with us about her new book, which is out in the world right now. So please go pick up a copy at your local bookstore, or we've left a link in the episode description. As always, if you want to drop us a line and let us know what you think about the episode, or maybe there's some questions you have or suggestions for future episodes, shoot us an email, tinymatters@acs.org. You can find Deboki on Twitter at okidoki_boki, and you can find me on Twitter at samjscience. We'll see you next time.